Assalamu alaikum. How are you, students? Hope you all are fine. So, dear students of Standard 9, welcome back to my physics class. Dear students, you know I am taking chapter 8, that is reflection of light, from your physics book, and I have already taken 3 classes on this chapter. So, today this is lecture number 4, and today I will explain ray diagram in a spherical mirror. So let's start the class. So images formed in a spherical mirror. Dear students, you know about a spherical mirror from my previous content, and today I will show images formed in a spherical mirror. If an object is placed in front of a spherical mirror that may be concave or convex, an image of the object is formed in the mirror. To know the position, size, and nature of the image, we have to know the direction of the reflected beam of light emitted by an object. We can draw an image in a spherical mirror considering any two of the 3 rays described below. Number 1, rays incident along the radius of curvature returns back along the same path after reflection in a spherical mirror. So let's look at this figure. So rays incident along the radius of curvature returns back along the same path after reflection. Look, here ray is incident on the spherical mirror along through the radius of curvature. Then after reflection it will returns back to the same path or same direction. Look, this is convex mirror and this is concave mirror. And here students, it is very much important to know which one is concave mirror and which one is convex mirror. So it is very easy to remember. You have to see from which portion reflection is occurring. The mirror is named according to that. Look here, the silvering is done on the convex portion and reflection is occurring at the concave portion. So it is concave mirror. And look, this is convex mirror because here silvering is done on the concave side or concave portion, but reflection is occurring in the convex portion. So it is a convex mirror. And in the both mirror, if light is incident to the center of curvature, then it will returns back to the same direction. Now, number 2, rays incident parallel to the principal axis are reflected through the principal focus in a concave mirror, and rays incident parallel to the principal axis after reflection in a convex mirror appear to diverge from the principal focus. So let's look at the figure. Look here, rays incident parallel to the principal axis. You know this is this principal axis, and the rays incident that is parallel to the principal axis. So after reflection it will go through the principal focus, and in case of convex mirror it seems or it appears to diverge from the principal focus. That's why we represent that by using this dot sign. Okay. Number 3, in a concave mirror, rays incident through the principal focus are reflected parallel to the principal axis. Rays directed towards the principal focus after reflection become parallel to the principal axis. Look here. Rays are directed to the principal focus, but after reflection it will be parallel to the principal axis. Look here. The ray is directed towards the principal focus. Here it appeared to be diverged from principal focus. The rays directed towards the principal focus and after reflection parallel to the principal axis. So you have to, when you will draw a ray diagram, you have to remember these 3 points. That means when, again I am summarizing, when light is incident to the radius of curvature, it will return back to the same direction. When light is incident to the principal focus, it will be parallel to the principal axis after reflection. When light is incident parallel to the principal axis, then after reflection it will go through the principal focus, and it is true for both concave and convex mirror. Dear students, now I will explain rules of ray diagram. That is, I will show you how to determine the position, nature and size of the image formed by a spherical mirror for different position of an object placed on the principal axis. So, we will determine position, size and nature. So, you have to understand what is position, size and nature. Position, that means distance of the image from the mirror. Nature, size, whether the image is magnified or diminished, or its size is equal to the object, that can be understood by the size. By size, it will explain that. Nature, whether the image is real or virtual, and whether the image is inverted or erect. So look here, this is the concave mirror. In the convex portion, silvering is done, but it is not shown here. So look, this is radius of curvature, and you know, radius of curvature to pole, the distance, the length is known as principal axis. So this is PC is principal axis, and you know, principal focus is half of the radius of curvature. Okay, so F will be the midpoint on the line CP or PC. This is pole, P is the pole, F is the principal focus, and C is the radius of curvature. Okay, center of curvature. Sorry, C is the center of curvature. And you know, the line that passes through center of curvature and pole, that is known as principal axis. So this line is principal axis. Look, here I will determine the position, size and nature of the image, and when the object is placed at this position. Okay, number 1 position is what? That is when object is at infinity. Number 2, when object is in between center of curvature and infinity. Then number 4, when the object is between center of curvature and principal focus. And number 5, when the object is at principal focus. Number 6 position, when the object is between pole and principal focus. So for this position, we will determine the position of the image on the mirror. So it is very easy to find out, and there is a shortcut technique. You have to remember that position of the object plus position of the image equal to 6. Okay, that means if you add the position of the object and position of the image, you will always get the addition sum will be 6. Look, so if the object is at the position 1, then to get 6, the image position will be what? 5, and 1 plus 5 equal to what? 6. Okay, if the object is at the position 2, then the image will be formed at the position 4. Then look, position of the object plus position of the image equal to what? 6. Similarly, if the object is at center of curvature, that means position 3, then the image will be formed at the position 3. If the object is at the position 4, then the image will be formed at the position 2. If the object is at the position 5, then the image will be formed at the position 1. If the object is position 6, then the image will be formed behind the mirror. So in every cases, you can get the sum is what? That is equal to 6. Here, you have to remember from position 1 to 4, the image will be real and inverted. If the image is real, then it must be inverted. And if the image is virtual, then it must be erect. So from position 1 to 4, the image is real and inverted. And at position 5 and 6, the image is virtual and erect. If the image is virtual, then it will be erect. That means straight. And size can be diminished, magnified, and equal. And nature will be what? Virtual and erect, and real and inverted. So now I will show you two examples where I will find out the position of the image depending on the position of the object. So the position, size and nature of the image formed by spherical mirror depend upon the position of the object placed in front of the mirror. If the position of the object with respect to the mirror changes, the position, size and nature of the image also changes. That is shown by this diagram. So let's look at the example. Look here. When the object is at infinity, so from the topmost point and from the lowermost point, when rays of light are parallelly come from the object which is at infinity, then after reflection, the reflected ray will pass to the principal focus. So the image will be formed at the principal focus, because you know principal focus, this is position number 5, and infinity, this is position number 1. So when the object is at infinity, then the image will be formed at the principal focus. So here the image will be created at the focal plane. If we consider here a plane, so that is known as focal plane. So at this focal plane, the image will be formed. The image will be real and inverted, and it will be extremely diminished. The image will be extremely diminished. Look here, the object is at the center of curvature. Okay, object is at the center of curvature. Look, at the point B and C is the similar point. So AB is the object which is situated at the center of curvature. Look, from the topmost point, the rays of light is incident, which is parallel to the principal axis. Then after reflection, it will move to the principal focus, you know, from the rules. And if another ray is incident to the principal focus, after reflection it will be parallel to the principal axis. So the image is formed at the center of curvature. That means here the position of the object is at number 3, that is center of curvature. So the image also will be formed at the position number 3, that is center of curvature. Okay, so in this way you can find out other diagram, that is when object is situated between infinity and center of curvature, then object between center of curvature and principal focus, object at the principal focus, and object between principal focus and pole of the mirror. Dear students, you must practice the ray diagram by drawing it in your copy, and you must draw it by using compass. So in this way you will take any point that is center of curvature. So keeping the compass here, you will draw an arc that represents the concave mirror, and at the midpoint of this arc, that is the pole, then joining P and C, we will get principal axis, and F is the midpoint of PC. So how can you determine F? It is very easy. You will place the compass at point C and draw an arc here and here, again at point P, and draw an arc here and here. Then by joining those, you will get a point here that represents the principal focus, which is the midpoint on the line PC. Okay, so dear students, we have to practice ray diagram, because from this chapter, by using ray diagram, creative questions can come in the examination, and also for solving MCQ you will require this. So today, after this, I am to finish my lecture. In the next class, I will explain some more interesting topics. So till then, stay safe and stay strong. Goodbye.